Good day, YouTube. This day I would like to demonstrate to you guys on how to check battery problems, especially if the battery will drain overnight. So first I would like to demonstrate sort of illustration the setup of the battery in the vehicle. So we have the battery, and we have two posts or terminal posts. Then we have the fuse box. Okay, so your positive cable from battery directly connected to your fuse box. Then in your fuse box there are some fuses and relays. So basically the fuse is supplying power to the relay, and now from relay you can have your component like your compressor, for example, your computer, your lamps, your some other components like your headlamps or some other courtesy lamps. Okay, and your negative cable is directly connected to the body of the vehicle. Either it is the body, and some will go directly to the engine. So this is the basic setup of your battery in your car. So now, if you have some fuses or if you have some components that are always on, even the ignition is off, okay, for example, your lamps is always on, your compressor clutch is engaged, even without turning on your ignition, this will consume the current of your battery or the charge of your battery. And we don't need this, because this is the reason why we have an overnight problem. Tomorrow you cannot start your vehicle. Okay, to set up this one, to check using this meter, we have here the fluke digital multimeter. So the basic function of this one, it can measure the alternating voltage. Okay, I will use the knob. Direct voltage, okay, or the current, millivolts, ohms, diode, milliamps, DC or AC amps, and microamps. So today we're going to use these milliamps, and since this illustration here, the display, you can eliminate this one, is AC, so we need to change this one to DC to check the battery of our vehicle. So we'll press this. So now we are on DC or direct current, okay, to measure the amps. So setup first, okay, we need to identify. So this is our common, you can see it there, and this is our amps. So our cable, we need to put this cable, the red one, in your amps, and the black one in your common. Okay, so that's it, the setup. So where we will put this one in our vehicle, what we'll do first, okay, you need to open doors. You need to open all doors. Okay, then you need to open your bonnet or your hood, your trunk, and you need to lock them, the latch, okay, your hood latch, you need to close those, and your open door latches. So the doors now are open, but the latches are closed. So you need to close those. What is the purpose? So that you can access anytime whatever components inside the vehicle if you want to check those things. Because you are suspecting that we have components that are on, and we need to check the fuse, for example, to check if the battery is draining. So what is the setup? Okay, here in this particular part, we need to make this meter in series. So what is series? So we will do another picture here. Okay, this is your negative, this is your positive. Okay, here is your negative, and here is your, no, sorry, this is your negative and this is your positive. Okay, so in series, so basically it looks like this. So in between your terminal post and your cable, you will set up this meter. Okay, so now all of this current will pass through the meter, okay, before it will goes to the ground. That's why you don't need to open anything with your doors, lamps, whatsoever, because the capability of this meter is to check only 10 amps. 10 amps is just a little amount of fuse to hold load. For example, if you open your headlamps is, for example, maybe it will give you 5 amps. It's fine. But the doors, once you open the door, maybe 20 amps will pass through this meter. It will damage our fuse. Then to check also if we have an existing amount of drain, which is below 10 amps, to protect the fuse of your meter, you need to use this fuse. Okay, a jumper fuse here, 10 amp jumper fuse. What you will do, once you disconnected the battery cable, you will put this fuse here, and you will stay there for 2 to 3 minutes. And if the fuse, this fuse is not blown, meaning although we have current drain, current passing through the fuse, but for sure it's below, or maybe 10 amps below. So now it is safer to use your meter. Okay, so you put your meter there. Since you set up already to amps and your common or your negative, and you set up the knob to amps DC, then this will display the amount of current flowing through the circuit from the battery to the negative. Okay, so if you have current drain, for example, you have here 30 amps or 30 milliamps below, then you are good to go. But if you have 30 milliamps above, okay, that will cause your battery, okay, to drain. So that is our objective. So for example, you got like 1 amp, okay, it's a quite big amount of current. Now your fuses here is your next target. So monitoring the reading of your meter, for example, you got here 1 amp. So you will remove individual fuses. For example, you remove the computer, or you remove this fuse, even though without knowing this fuse, just remove this fuse and it drops. Okay, the value drops to 35 or 30 or 10 or whatsoever. So it's, if it is below 30, then you are safe. So you can consider this fuse now is causing the problem. So check the fuse. Then next will be your relay. The closest to your fuse that can cause the problem is your relay. Okay, your relay. Then after that one, if your relay is good, easiest way to check your relay, you can swap from this relay. Just look at the structure. If it is the same, just remove the relay of your suspected line. Then you swap this one. If the drain is below 30, even with a new relay, then you consider your relay has a problem. So that's how we use the tool to diagnose the parasitic drain. Okay, thank you so much for watching. I hope you learned something out of this simple demonstration.